All right, let's take a look at these two questions. First one, antiderivative of x squared is 1/3 x cubed, of 2x is x squared, and of 3 is 3x. Good. Remember the notation. We use the square brackets and our bounds from -1 to 3 on the right side once we have the antiderivative. Then we can plug in the 3, plug in the -1, and subtract. And it looked like lots of people were ending up with -32/3 or -10 2/3. Any questions with that? Sorry, did you have a question? Oh. Thank you. Me too. Okay. Number 2. Oh, so what does this number mean? So the area between -1 and 3. So we have a negative area, which is kind of weird. What does this graph look like? So if we looked at this, in factored form, it'd be what? X minus 3, x plus 1. So it has zeros at... Oh, yeah. So it has zeros at +3, -1, and our graph curves like this. We found this area, but because it's below the x-axis, it makes it negative. Okay. Well, it's not a negative area. It's actually more just telling us it's below. Okay. So for the next one, antiderivative of cos x is sine x, from 0 to pi, and we get 0 area. But no, because if we think of the graph of y equals cos x, our graph would look, there's pi. So we found this area and this area up to there. And guess what? They're the same size. So this one ends up being positive. That one ends up being negative. When we add them together, we get 0. So is the area actually 0? No. But if we wanted to find the area between the function and the x-axis, we'd have to do a bit of work, which is what we're getting into today, finding the area between two curves. So this is lesson 10.2. But we're going to do it using definite integrals, which is why we did 11.2 already. So put your pencils down, just watch what I'm going to do, and then I'll give you some time to write down later. Okay? If I want to find the area between f of x and g of x, what I could do, this thing is jumping around too much today. What I could do, there we go, is find the area under f of x, which is just the definite integral from a to b. And then if I found the area under g of x, then I could just subtract them. And that'll give me this area in between. Good. So, oh, that's later. We could write it like that. So we could do the integral separately. But since the bounds are the same from a to b, we could just say this is the integral from a to b of f of x minus g of x dx. Both ways work. So you can use either way, find the area of the one, area of the other, and then subtract. Or subtract the two functions first, and then do the antiderivative. Good. Now suppose our functions cross the x-axis. Then, as we look at these two functions, and those two functions, they're actually the same except for what? The vertical position. Yes, your hand waving communicated that. So what I could do is I could just add some constant to both of them, and then it turns into this, right? So I could just add the same number to both, and then I get them both above the x-axis. But when I do that, Sharia, stop talking. I'll have f of x plus c minus g of x plus c, and guess what happens? The c's just cancel out, so it doesn't even matter. So it doesn't matter if one graph is above, one graph is below. We can just subtract the two functions and do the antiderivative. That'll give us area between the curves. That's it. Not too hard. Yes?
Why isn't it like cancel out in this type of question, or this type of scenario in a sense?
What do you mean? What is?
You know how in the moral question 2 or 2, it was like,
Yep.
they're both equal, right? So it's almost positive, one was negative, cancel out. But areas were. So why doesn't it cancel out this one? Why do you use the same answer?
So if we were to kind of do the antiderivative from here, we'll go green, this will be positive, and this will be positive, and this will be negative. Okay, and then for my g of x function, all of this would be negative. So when I subtract this black part, I'm subtracting a negative, which means I'm adding it on. So I'm adding on this piece, but I've also subtracted it out, so it doesn't get included in the difference. And all the green part is already positive. All the black part, I'm subtracting the negative, so it gets added on, but then this red part gets subtracted again. So we still get the area in between. Good. So let's do a few examples. Oh yeah, I didn't let you write it down. Yes, you can pull out your notes, write down what's going to be helpful, and I'll pause the video. Everybody good with this page? Okay. Your quiet attention, please. So, two-ish steps in this process. First of all, so I have these two functions. I want to find the area between the curves on the interval from 0 to 2. The question we have to keep in mind is, do these curves cross somewhere in this interval? Because then we need to do some manipulating to figure out the area in between. So that's where we start. We will figure out, do these graphs intersect somewhere in the interval? So I'll solve using substitution. So the x cubed plus 1 equals the 2x minus 3. Collect it to one side. We have a cubic, so think of the factor theorem. Factors of 4, positive negative 1, positive negative 2, positive negative 4. And what I've shown so far, negative 2 does make it equal to 0. So I found one factor. So they intersect when x is negative 2, not in the interval. But that's only one possible point. It's cubic, right? So they could intersect at 3 points. We found one. So then I'm going to do the synthetic division, which will give me a quadratic as my other factor. It's not a factorable quadratic. But that doesn't mean they don't intersect. So quadratic formula or discriminant. What's the discriminant from the quadratic formula? B squared minus 4ac. So that's what I'm going to do. Test out b squared minus 4ac. My b is a negative 2, so that'll be a positive 4 minus 4 times 1 times 2 minus 8. It's less than 0, so there are going to be no more intersection points. Whew. The question would have been harder if we had an intersection point, so we'll save that for later. So in our interval, the graphs don't intersect with each other. So then we can just use what we developed on the previous page, which is, oh yeah, but first we have to figure out which graph is above the other one, because you can't just arbitrarily subtract them. So yeah, we'll look at some point that's in the interval, like 1. And let's look at our first function for y equals 1 cubed plus 1. Y is 2 when x is 1. Good. For the other one, y equals 2 times 1 minus 3. So y equals negative 1 when x is equal to positive 1. What's bigger, 2 or negative 1? 2! So that's the function that's on top. So we know the blue function is going to be on top. And so now I can do the definite integral from 0 to 2 of x cubed plus 1 minus 2x minus 3 dx. Remember the square brackets. On the previous page, I said we could do these antiderivatives separately. I'm going to come up with a simplified function first, but you know how to do this. So I'll let you get a head start here. I'll pause the video and then continue on in a little bit. So I did have a mistake, and I corrected it in green there. So now we can evaluate this. Okay, so some of you saw that I was making a mistake in my work as I went. And handily enough, once I got to this point, so I had a 2 instead of a 4 there, a -2, I was getting a negative, and I thought, well, that's impossible. Because as long as I'm doing the top function, subtract the bottom function, has to be a positive value. So that's something to keep in mind. If you're expecting a positive and you get a negative, you know, oh, something fishy happened, go back and check your work. So that's what happened to me. So I fixed all those, pardon me, turned them into +4s. And then we'll have 2 to the 4th is 16 divided by 4, 4, 2 squared, 4, plus 8. And this 0 over there, that's if I plug in 0 for all of these x's. So that's subtracting the second part. And so I end up with an area of 8. Rian. So it'll always be positive because as we look back at this one, we're going to take this area up here that's positive. And down here, we're going to subtract this negative area, which means I'm adding the black part to it. Doesn't matter. I'd have, if both were underneath, so let's imagine that. So here's one graph and my other graph, and I want to know this area here. So for this top one, let's keep that going up, I'll get, that is going to be a negative area. And then I'm going to get all of this. It's also going to be a negative area. But I'm going to do the top one. So I'm going to do, let's say that's top area, and I'm going to subtract the bottom area. So the top one is negative, so this is going to be some negative value. But then here I'm going to subtract a bigger negative value, which means it's going to be positive. There's my very mathematical description, but does it make sense? Yep. Well, it can't be. If they're both below the x-axis, this red area has to be bigger than the green area. Try to draw something where it's not true. Any questions with number 3? We're good? All right, next question. This time we're not given boundaries. We're just asked, what is the area between these two curves? So, we need to begin by looking at where do these two curves intersect? So why don't you do that? Find out where do these curves intersect. Once we do that, then we need to figure out which function is above the other function. If it changes, then you have to do a couple things, which may show up in a question yet. You'll have to find out. We got -1 and 2. We're all good. So if we were to visualize what's going on here, and we looked at this quadratic, opens down, so you have this quadratic vertex is here, and it opens down like this. And then we have this line, -x minus 2. So we have a line that goes down kind of like this. So when we're asked for the area in between, we're looking for the area that's enclosed. So we want to know what's this area that's enclosed by the two. This area out here, we don't care because it's infinite, so not helpful. This area over here, infinite, not helpful. So we don't care about those. We only want to know what's enclosed between the two curves. And we only have the two intersection points, so it makes it relatively easy. So now this gives us our bounds, and from my knowledge of the graphs, I know which one is above. But if you can't tell, then we do what we did in the previous one. We pick some value for x and we plug it into the two functions. So for my blue one, if I say when x is equal to 0, y is equal to 0. And then for this green function, when x is 0, y is equal to -2. So then I know the blue one's above the green one. Or the quadratic is above the linear function. Yep.
It'd be like the intersection question with given bounds.
Yep, it could happen. Yeah. So which is why for this previous question, even though we were given bounds, we looked to see where the intersections were in case it was inside the interval. Be careful. There's a question on the test. I don't tell you, but you have to be alert to, does it intersect in the interval? And then you need to make an adjustment for that. Okay. So we can do the integral from -1 to 2 of the blue function, -x² minus the green function, which was -x minus 2. And again, I'll give you some time to work that out. They'll never know what we were just talking about. Any questions? Fabio? Nope, you could write it as 9/2. That's good. Fractions are generally preferred to decimals. Okay, a few people have asked, what do we do if there is an intersection in the interval? And I looked at the next question and it doesn't show up there. So suppose I gave you a new question, which was, let's find area between the x-axis and the curve. We'll say it's f of x equals negative 3x squared plus 1. I'll make it easy to find the antiderivative of on the interval from 0 to 2. So suppose that was the question. Sorry, this doesn't look very good, but that's a negative sign there. All right. So we start by looking for, where are the zeros for this? Oh, maybe I should have a nicer number. Yeah, let's make this a nicer question. Let's make that a 3. Then it's easier for our brains because we just want to get the idea. Okay. So I'm interested, where is that equal to 0? 0 equals negative 3, I'll factor it out. X squared minus 1. If I factor the negative 3 out, which is 0 is equal to negative 3, x plus 1, x minus 1. So we get x equals negative 1. Is it in our interval?
Yes.
No. No, we don't care about that one. But this one, x equals positive 1, that's in our interval. So, yeah, let's do it without drawing it. So we're going to say, my function, let's look to see what is f of 0 equal to, and what is f of 2 equal to, because that's on either side of that intersection point. And f of 0 is going to give me 3. That's good, so my graph is above the x-axis. F of 2 is going to be negative 12 plus 3, negative 9. So there's going to be below. So even if I have no idea what this curve looks like, I'm going to just do a really gross approximation and say, just imagine this is a line. So they intersected when x was 1, or it crossed the x-axis. So let's just pretend my graph was like this. Is it? No. But pretend it was some function. I have no clue what it looks like. I do know that over here, at this point when my x is 0, this value there was 3. And here, when x is 2, this value here, 2 comma negative 9. So it's somewhere down there. So what I'll do is I'll find, well, what's this area? That's the easy part. So I'll do the integral from 0 up to 1 of my function, which is negative 3x squared plus 3 dx. Good. And I'm going to add on to that blue, this area that's there. But I know it's going to be positive. So I think of it as two functions. I have this function, which is y equals 0, and I'm going to subtract the red function from it. So I'm going to have the integral from 1 to 2 of 0 minus my function, which was negative 3 x squared plus 3. Make sense? So I'm imagining I have this y equals 0 function, and I'm going to subtract the area that's below, so I'm subtracting a negative area, which will make it positive. So this is one way to think it through what's happening. Usually what we'll do is we won't even just write in the 0. We'll just take the negative of this integral because we know the sign has to switch. Okay, so I could rewrite this as the integral from 0 to 1, negative 3x squared plus 3 dx. And then I'm going to subtract the integral from 1 to 2 of negative 3x squared plus 3 dx. So I'm subtracting that negative area. Yep. Yep, you can skip the first step. I just wanted it to be clear why we're doing this. And then we go through and figure out the answer. All right. So, do you want to finish this question or just go on to the next one? I'll give you time, and I'll write up an answer for this one, and then we'll do the next one as well. Hello, people in video land. For those of you who did this question, I'm getting 6, you got 6. Okay, so we won't have time to go over the next one today, but I will post notes on EDSB today. End of lesson. Goodbye, video people.